All right, so this next thing we're going to be talking about is how to graph things graphically with our exponential functions, okay? So what I'd like you guys to do for graphing exponential functions is I'd like you guys to write, we're going to do f of x instead of y. So put f of x equals a times b to the power of x. Just remember, in your exponential functions, your a value is always your initial value. Okay, that's your initial value. The b, what you start with. The b value is either your growth or your decay factor. So if the b value is greater than 1, that means it's going to be growing. Okay, that's growth. So this graph, the way it looks right here, this is what's called a growth function. If it's a decay, it would look like this. It would be going down like that if that was a decay function. Okay. Right now, like when you start growing as a kid, I tell you what, you start growing as a kid, you'll start seeing like an exponential growth, okay? But then when you die and your body starts decaying, the matter over time, it exponentially decays and gets closer and closer and closer to zero. But you know, you never quite get there because you're still dust, okay? All right, so if the b value is less than 1, don't worry, we'll all get there someday, or greater than 0, oh, I can wait. Trust me, one of my students said she can't wait. I'm like, I can wait, all right? All right. I can already see my hair's already decayed. Okay. All right. I think it just transferred from my head to my beard. All right. So we got decay factor. So what does that mean? That means right here, see this x value? When x, ready? When x is 0, the y value will be your initial value. Okay. All right. When x is 0, the y value will be that initial value. Okay. All right. So, for example, you're like, what does that mean? I have no idea what it means. It doesn't make any sense. So here we go. If I said y equals 3 times 2 to the power of x, and I made x 0, what would my y value be? What's my a value? All right. It'd be a 3. But if I had y equals 2 to the power of x, does anybody see an a value there? No, you don't really see it. So if you don't see an a value there, you automatically assume there's a 1 being multiplied to it. So here, since you can't really see the a value, if I plug in a 0, you're just going to be at a 1, because that's, if you don't see an a value, it's going to be a 1. Okay. So what happens when we have situations like this where there's a power right there and it says 1 minus x? What I'd like you guys to do right now, we're only going to do this for a few short minutes. I want you guys to go to Desmos, and I want you guys to see what happens in the graph when you mess with the exponential realm up here. Okay, so if you guys would please, let's go to Desmos real quick. This will make a lot more sense if we just do it in Desmos. You'll see the pattern, and you'll be happy. Well, you won't be happy because you're teenagers, but you'll be semi-content. Okay? All right, so here we go. So type in f of x equals, and I'm going to go 2, since that's the easiest one to see. 2 to the power. Now, if you would please, can you guys put a little parentheses right there? Put x, like that. Okay. Does everybody see we're at a 0 and a 1? Okay. Now look what happens when I say x minus 1. What happened? Now we're at a 1 and a, we were at a what? A 0 and a 1. Now we're at a 1 and a 1. Okay. So how about this? I'm gonna take. I think it probably better. I'm gonna start taking screenshots. Here we go. Take a screenshot. Boom. Got that. Now I'm gonna put x minus 1. Okay. And I'll take a screenshot. Okay. Then I'll do x minus. How about this? X minus 3. Take a screenshot. All right. Let me go back now. Here we go. So we were right there. Oh, not there. Then we're there. Then we're there. What's happening to our graph. What do you think is happening in our graph right here? It's not stretching. It's shifting. It's shifting what direction? To the right. So our very first graph right here, our very first graph, we were at a what? We were at a 0 and a 1. The next graph right here, we're at a 1 and a 1. Where do you think we're at there? Where is this right here? 3. Where is that right there? So that's at a 3 and a 1. So what is this up here also due to our exponential graph? It shifts it left or right. So check this out. If I go over here and I change that from a negative to a positive, oh, look where I am. I've moved what, 3 units to the left. Okay? So guys, right now, where is our horizontal asymptote right now? It's at y equals, not that, hold on, y equals 0. This is our horizontal asymptote. But if I change this, everybody, and I say I'm going to put, say, a plus 5, what do you think I have to do with my asymptote? If I have a plus 5 at the end, I got to move it up. So now it's not y equals 0. It's at what? Y equals 5. If I move this and I say I'm going to shift this down 5, uh-oh, I got to change my asymptote. So where's my new asymptote going to be? Negative 5. So when you're doing the Khan Academy, you got to make sure that you move your asymptote up or down depending on your problem. Look what happens if I put a negative inside on the outside of this. Look what happens to the graph. What does a negative on the outside do to the graph? Does it change your asymptote? No. But what happened in my graph? It went from this to this. So what does it reflect across? It's reflecting it across the x-axis. You're like, no, it's not. It's reflecting it across negative 5. But what was that before we shifted it? That would be the x-axis. So that negative still reflects it across the x-axis. Okay, so be aware of that. What happens if I put a negative x right there? Look what happens. I don't know if you guys can see it. What does this reflection on the inside do? Reflects it across the y-axis. Can everybody see how this is being reflected across the y-axis? Back and forth. So you just need to be aware. When you guys are taking a test, I'm going to be asking you what's happening. And you can't just look at it on the graph. Sometimes you got to know what it says in the equation. Okay? So on the inside, it reflects it across the y-axis. On the outside, it reflects it across the x-axis. So yes, will I let you guys use Desmos to help you out? Absolutely. But right here, you see that plus 6 right there? What does that tell me? That tells me where is my horizontal asymptote going to be? At 6. So what do I got to do with this baby? Well, I got to move this down, and then I move this up. See how you have to move your horizontal asymptote, okay? So right now, I want you guys, we're going to do one quick little, oh man, it's almost time. So right now, I'm going to have to pause, okay? I will add on to the video later. But right now, I want you guys can use Desmos, just make sure you set your asymptote where it needs to be, and you got to find how many points to make it work? 2 points. So you can use Desmos to find those 2 points. And make sure your asymptote's in the right place. All right? Because you guys need to get your asymptotes out of my class here soon. All right?